This is problem 7-59 from section 7.1.4 homework. It says solve 3 to the x plus 5 equals x squared minus 5 using any method. So we've seen questions like this kind of a lot in the last couple homeworks where I have something equals something else, solve for x. So one, we've talked about solving something algebraically before. Now this one I have an exponential value, and I have something to the squared. So those are kind of two different types of functions. So that might be kind of a challenge to try to solve this algebraically. So let's go ahead and graph them. So in y equals, I'm just going to draw, or type in the two sides separately. So I have 3 raised to the x, and I add 5. Whoops, that's what I don't want to do. So 3, the x is the only thing in the exponent. Then I go down and say plus 5. Second part is x squared minus 5. Okay, so we're going to graph these and we're going to look for the intersection point. And I zoomed out originally, so I'm going to zoom this back in once our other graph shows up, because it's kind of hard to see the values right now. So I'm going to hit zoom, and zoom 6 brings you back to the typical window size if you're ever not able to see your graph. So I know the left side, this blue equation is an exponential, and it's raised up at 5, and its multiplier is 3, so it's going up quickly. And my second one is a quadratic that's just moved down 5 spaces. So what I can do is I can check my intersection point by possibly two things. We could either do trace and just kind of go along here until our lines meet, or we can show us something else. We can do second, and the button calc there is we're going to calculate the intersection. So number 5, and it says first curve, so we just need to be on the blue one somewhere. Could be on either side of the intersection point, but somewhere kind of close so you know you're on the blue one. Second curve is red. I'm going to move up a little bit there. Okay, so I'm getting closer to my intersection point. Guess, if you want to move your cursor up to where we guess, I'm pretty close there. The guess really doesn't matter. And the intersection point, here's where we need to kind of figure this out. Intersection point says negative 3.16, if you can see way down in little letters or little numbers down there, negative 3.16, and y's coordinate is 5.03. So if we look back at our original equation, are there any y's in the equation? No. So I only want x to be in my answer. So my answer for x is going to be x equals about negative 3 it was negative 3.16 7, so I probably should round it up to that. So let's change this to be about negative 3.17. Okay, so that's my approximation. So using my graph, I see where the graphs intersect. Now I want to zoom out a little bit. We were zoomed out before, but just to double check that there isn't another intersection point higher up in my graph. So let's see that. So there's my one curve. And my parabola. There we go. Okay, so we see our parabola is going farther and farther out, and my exponential value is just going up kind of a little bit farther out, but my parabola is moving to the right more quickly, so I'm only going to have that one intersection. Okay, so I use my calculator to graph them separately and get x equals about negative 3.17.